Not every user question belongs in vector search. LlamaIndex query routing lets a Python assistant choose SQL or RAG before it wastes context. This is the setup you'll be able to run after this, which routes each question to tables or documents and returns the chosen path and answer. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Many teams mix structured data and documents. You might have sales totals in a database and shipping policy in a handbook. If every question goes into a vector index, you pay for embeddings and risk hallucinated numbers. Success here means fast, exact answers for aggregates and grounded, contextual answers for narrative queries. Query routing gives you that split decision in one assistant. Intuitively, routing asks a question. Is this a structured math request or a free-form reading task? If it looks like an aggregate, hit the database. If it needs reasoning across text, use Retrieval augmented generation. That saves latency and improves correctness. We will build a tiny demo that shows both sides. You will see a small sales table that answers totals and 2 policy documents that answer shipping questions. The Python router will pick SQL for sums and LlamaIndex RAG for everything else. Now let us start with the data setup. This snippet creates a tiny in-memory sales table in SQLite and links it to a LlamaIndex SQL database for later query routing. The connection variable con opens the database and immediately defines the sales schema with product, quantity, and price. The execute many call inserts a few rows to make aggregate math meaningful. The object SQLDB is the LlamaIndex wrapper over the existing SQLite connection. So higher-level tools can reference this SQL source without changing drivers. A simple aggregate selects the total revenue by multiplying quantity and price and rounding. The printed total shows the numeric ground truth your SQL engine will return when routed correctly. Next, we build the retrieval side and local mocks for deterministic output. This example constructs a tiny RAG setup in LlamaIndex using 2 short policy documents. The list docs holds document objects with clear human-readable text. The settings object assigns a MockEmbedding and a MockLLM, so everything runs locally and deterministically without external services. The VectorStoreIndex builds a searchable representation of the documents, and RAG is a query engine produced with similarity top K set to 1 for tight retrieval. The final query asks about express shipping time and prints a short slice of the synthesized response. Increasing similarity top K broadens retrieved evidence, which can improve recall but may add latency and verbosity. Now we add a simple router that decides which engine to call. This code introduces a minimal, deterministic router that directs each question to SQL or LlamaIndex RAG. The function route takes a query string and normalizes it to lowercase. It checks for aggregation cues like total, sum, or AVG, and if found, executes a direct SQL aggregate over the sales table using the existing connection. Otherwise, it calls the RAG query engine created from the LlamaIndex VectorStoreIndex and returns a short slice of the generated answer. The pair ENG and OUT captures which engine handled the request and the corresponding result. The printed line confirms the router correctly detected an aggregate and used SQL for accuracy and speed. Next, we let the SQL path accept a product name to scope results. This snippet adds an entity-aware filter to the SQL path, so routed questions can scope aggregates by product. The helper function SQL sum accepts an optional product name and executes a single parameterized query that either filters by P or returns the overall sum if the parameter is null. Using con.execute keeps the code compact and safe from injection. The variable pen total demonstrates a targeted total for the product pen, computed directly in the database for accuracy and low latency. The printed value shows the filtered aggregate, which is the key building block for precise, structured answers in a routed system. Finally, we combine both paths and show routing on a set of queries. This example composes the full baseline, a rule-based router that dispatches to SQL with optional product filtering, or to LlamaIndex RAG. The function SmartRoute detects simple aggregation intent and extracts a product entity when present. For aggregates, it calls SQL sum to compute a precise answer inside the database. For everything else, it queries RAG to ground responses in the indexed documents. The list QS holds two questions, one structured and one unstructured, and used captures which engine served each. The printed counts verify that queries were split appropriately between SQL and RAG, demonstrating a working end-to-end routing flow. In a real project, this pattern maps directly to user-facing assistance. The SQL side scales to large tables with indexes and fast aggregates. The RAG side scales with an ANN index and a larger document store. The router can evolve from simple rules to a tiny classifier that learns intent from examples. Recap: it is a rule-based query router that picks SQL for structured aggregates and LlamaIndex RAG for document reasoning. Use it when you mix numeric databases and text collections and need correct numbers plus grounded explanations. One caveat: rules are simple and can miss complex intent, so monitor misroutes. Next step: tune similarity top K on the RAG index and measure recall and latency, or add an ANN like FAISS for faster retrieval as your document set grows. If practical AI engineering helps, subscribe and watch the AI engineering videos.